누구나 매경의 지금을 보지만 매경은 우리의 다음을 내다봅니다. 시대의 변화에 앞서 먼저 변화하고 콘텐츠의 미래를 디자인하는 미디어 이상의 미디어. 이것이 매경 미디어 그룹의 오늘을 있게 한 힘이며 내일을 기대하게 만드는 이유입니다. 대한민국의 오늘을 이끄는 CEO들부터 대한민국의 내일을 이끌어갈 대학생들까지 폭넓은 계층의 전폭적인 신뢰 속에서 시장이 뽑은 대표 명품 신문의 명성을 이어가고 있는 매일경제신문은 우리 경제의 질적 성장을 위한 명품 기획 시리즈를 통해 시장 경제의 든든한 버팀목이 되고 있습니다. 국내 최초의 유료 디지털 신문이자 유일한 성공 모델 매경 E-신문은 20만 독자에게 영역별로 특화된 프리미엄 콘텐츠를 제공하는 심도 있는 버티컬 미디어로 자리 잡았습니다. 자체 영문 뉴스는 물론 글로벌 미디어들과의 콘텐츠 제휴로 독자들의 시야를 세계로 넓히는 동시에 블록체인을 활용한 비즈니스 모델을 발굴, 새로운 미디어 트렌드를 주도해가고 있습니다. 세상의 변화를 읽는 통찰력과 그에 기반한 아젠다 세팅 능력은 매경만의 독보적인 강점입니다. 시대의 화두를 집단지성으로 풀어냄으로써 아시아를 넘어 글로벌 지식 브랜드로 자리매김한 세계지식포럼, 국가 발전을 위한 새로운 비전과 액션 플랜을 제시하는 국민보고대회, 미래세대 도전의지를 북돋우는 Y포럼을 비롯해 매년 세계 각지에서 펼치는 다양한 행사와 캠페인은 국내외적으로 큰 반향을 불러일으키며 대한민국 리딩 미디어 매경의 위상을 각인시키고 있습니다. 이제 매경은 초격차를 향해 달려나갈 것입니다. 콘텐츠의 격, 플랫폼의 격, 기술의 격을 높여 누구도 넘볼 수 없는 차이를 만들어갈 것입니다. 4차 산업혁명 시대 미디어 콘텐츠 산업의 퍼스트 무버로 자리매김할 매경 미디어 그룹. 차원이 다른 미디어의 미래가 시작됩니다.
will now begin the session titled Frida, Promoting Human Creativity Using Robotics. For this session, we are honored to have with us today Dr. Jin Oh, an Associate Research Professor at the Robotic Institute of Carnegie Mellon University. Dr. Oh is a leading expert in the field of robots and robotics, and her research has been featured in major media outlets around the world. Dr. Oh's current research is focused on developing high-level intelligence for robots in the domains of autonomous navigation and creativity. She is also the director of the Robot Intelligence Group, which is a research group that is working to create robots that can understand and also interact with the world in a more human-like way. I'm really excited to introduce Dr. Oh to you today, and she's a true pioneer in the field of robotics. And I know you will be inspired by her work as well. Please join me in welcoming Dr. Jin Oh.
Thanks for having me. 안녕하세요. Yeah. How is everyone doing today? Are you still awake? Okay. So today I'm going to talk about Frida. So let me first introduce, where does it go? Okay, so let me first introduce my team, my brilliant students and wonderful faculty collaborators who's making things all possible. And in my team, we work on the intersection between AI and robotics. So as you all know, there has been breakthroughs in AI space. And we believe robotics is the way to bring those breakthroughs into the real world through robotics. Okay. So I'm going to show a lot of different applications. At the surface level, they all look different. But I basically do two things. So one thing is I want to make the robot to work with humans, so coordinate with humans. And I'd like to use human language, natural language, for the robots. And I've worked with the robots on the ground surface and also the aviation and underground. And to complete my profile, I only need underwater and space. So there's a lot of applications in this domain, but I basically want to use language to command the robot to do things that we want. And using language just lowers the bar for the usability. So anyone, even children, can use robots easily. And when we use the robots, the big difference between just a language model is including perception. So how to interpret vision and language understanding together to take actions. Because actions are the only things that can make changes in the real world. Okay. And now I'm moving to the art, and many people ask this question, why? Why art suddenly? So let me explain why. Okay. So there are two main reasons. And the first one is, let me first ask this question. Who likes math? Come on, math is the most beautiful subject in the world. So it's a purest form, and we can study very, very complex problems in math in a very pure form. And just like math, art is beautiful. Art is like math. So do you know this quote? It's a famous quote. Just kidding. So I wrote this, math is like art. Okay. Art is like math, likewise. Okay, so that makes us to do a lot of difficult technical challenges in a fun way. So after starting painting and sculpting in my group, I was able to work on a variety of different core challenges in robotics, and more people come to us to work with us. So I wish I have time to go over all of these, but these are all, each of them is a specific field in robotics, and there are many people are working on each of these sections. And today I'm going to focus on two of these things and one more thing at the end. So one is how to reduce the gap between simulation and reality. Okay. And then the last one is rather important, and it's growing. Because we are generating contents and we are making changes in the real world, we want to be responsible. We want to make the AI and robots be responsible for what they're doing. So this is going to be an important topic to think about. Okay. And then the second part is more broader purpose of using art, and that is to create real-world human values. What does that even mean? Okay. So I'm going to give you some examples. So the first of all, real-world art is different from digital world. So you have seen OpenAI's DALL-E 2 and also Midjourney. Who's using these tools? Like, have you all tried? So these are amazing. It works great, but they live in virtual world. So we want to bring that great things into the real world using robotics again. So these images generated by DALL-E or Midjourney, you can print them. You can just send it to the printer and then get a copy. But it cannot be painted, because painting requires planning and taking each brush stroke at a time. Okay. And then the second thing is, this is my personal thing. I'm an old generation, so I don't want to see children just looking at iPad all the time, playing computer games. I want children to mess with paint and also work with the sand, play with the Play-Dohs, and interact with the real people. So we need some way to bring this next generation, future generations, back to the real world. Like in order to live and really situated in the real world. Okay. And then the second part is the self-expression. So art is just a powerful way to express our ideas. And when I say art, I'm not talking about the things that you can only see when you go to museums. I mean, they are also great art, greatest art you can find and you can appreciate at the museum. But art is just a way of communication. And think about children drawing. It's always giving this awe, which is kind of an emotion that kind of touches your inner side. So art should be everywhere. That's what we really want to promote. So, and this is a great way to express. So some of these paintings are here, and this kind of carries on what I care about. So we did a lot of paintings last year about the war. And you see the colors of Ukraine in the paintings, and also about women's rights. And these are the things that I care, but I'm not really a painter, but now that I have Frida to work with, I can create paintings to express my ideas, what I feel. Okay. So this list goes on and on and on. It just has so much human value. Okay. And then I'm gonna just play this cute video. This is my favorite part. So it's just
No, the painting robot, my favorite. Can the painting robot paint me a picture?
So this is Zach Manchester, another faculty member's son. He has all these cool NASA space robots, but his son loves our painting robot. Okay. And whenever I had a cool robot demo, everyone likes robots. Any kind of robot demo brings people crowd. But with Frida, I say kind of little bit different appreciation from people. So that's the part that I'd like to study a little more, like what people actually feel when they interact with Frida and see the artifacts. And this is, so the French children's magazine, and we made a cover page, and our names weren't even mentioned, but this is my favorite among all the media coverage that we have seen. I mean, this indicates that our work really reaches out to little children. So, okay. So that was a very long introduction and background information. So I'm going to tell you a little more about how Frida system works, just a little bit. So I'll give you 3 seconds to think about what you want to paint with Frida. So, 3. Okay, so you all have ideas, okay? Right. So how would you pass that idea to Frida? So how do we describe what we want? It's difficult, right? So communication is always difficult, but we have language. And language is not perfect. It has a lot of ambiguity, people misunderstand, lots of noise, mess. But that's what we use, and we are used to using it. So we will continue using it, supporting it. And then sometimes we use quick drawing. So whenever you have a conversation, you kind of draw something. So that's another way. And then when things are very complicated, like the pattern in the ceiling, I just pointed, like, I want something like that. So give an example, okay? So those are kind of quick ways to communicate ideas with another agent, either human or robot. So in the Frida system, we want to support all these different modalities to communicate with people. Okay? So recently we started using sound. So I'm super excited to have another PhD student starting his thesis on the topic. And whenever I say semantic goals, semantic means something that's meaningful to people, like something that has names, like we named something. Okay? So that's how Frida system works at a higher level. And then I'm going to kind of repeat the same thing using a different example. So semantic planning is given this high-level goal. Someone has to come up with a plan, which is a sequence of actual actions you can take. Okay? So navigation is a great example. So in this example, I'd say to the robot, like imagine you're that tiny robot on the corner. Navigate to the building behind the car. And you don't even know where you are, but you can just imagine some space and then come up with something called an initial plan. And how do we do this? It's so easy for us because we have seen a lot of similar examples, right? So we want to do the same for the robots, but when you're situated in like a particular specific environment, we need to customize the plan and revise our plans. And we can just do it because the initial plan is not that different from the new plan. And for the parts that we still cannot see, you can still use the same idea. You imagine the space, hypothesize what might happen, and then just keep doing it. Keep replanning as you collect more information about the real world. Okay. And then just use the same idea for painting. So I used the BTS is dancing as an example. And you already visualize that image, right? So that's the process that's happening inside like Frida system. So it imagines some image, okay. But this is only inside your head. Can you paint this? Then you need to take actions, so it goes into the planning stage. And the difference between navigation and painting is the action space. So whereas the action space in navigation is taking steps, like how to move, and in painting, brush strokes. So to me, the two problems look very similar. And I hope you now agree with me. Okay, so I'm going to go into a little technical part of how we reduce the gap between simulation and real world. Okay, and that's again, I forgot to mention Peter, a brilliant PhD student working on his thesis on this topic, and Jim McCann, a wonderful collaborator. And in the FRIDA system, what Peter is focusing on is how to reduce this gap between simulation, what you imagine and what you can actually do. And we also face that challenge too. You can imagine yourself doing all kinds of things, but when you actually want to execute a plan, you realize that there is a gap, okay? So it's difficult. And you might want to borrow the idea from Frida to apply to our own problems too. So the little bit of a past work. So we started like back in 2019, and when we first tried using some existing planning algorithm, and we used a very, very low-end, like $200 Amazon purchase robot, and the quality of the painting was very poor. It was almost funny. And our first approach was, let's reduce the gap, because the robot is not very capable. So can we generate the strokes that this tiny robot can actually paint? So we add handcrafted constraints to make the gap a little bit smaller. And the result was much better, so you can visually see. But the gap was still large. Okay? And then the next thing that we tried was using the real data. So let's have the robot to show us what they are capable of. So the robot kind of shows random brush strokes, maybe 200, 300 strokes, and then we collect the data and then train the simulator using those real data. So that's called the real to sim to real. So that makes sense, right? So this way, the plans or images generated by the simulator really matches with the real robot's painting. So it's a very high fidelity simulator for that, really customized for that particular robot. So we can use this idea for our planning. We need to understand what we can do, and then we plan the feasible ones. Okay, all right. So the result was, okay, this was the earlier one, and then the second one was the handcrafted one, and the third one was substantially better. So we got to do a lot more painting using this idea, and then more. So I'm going to stop on the painting part for now. We are continuing this work, so we will maybe talk more and show some kind of preview of what we are doing at the end of this talk. Okay. And then the second part is the fairness issue. So this is led by my master's students, and also collaboration with Professor Ji-hee Kim at Dongguk University across the street from here. Okay, so why do we even care? Because there are two major reasons, because diversity matters. And there is a scientific proof, and also AI knows diversity matters. So, or any type of machine learning or AI, essentially they're doing one thing. We want to find the best possible solution. And it's kind of a searching through gigantic space. And if you just work with people you know, your neighbors, people who look like you, then you get trapped something called local optima. And in Korean, there is an expression, 우물안 개구리. Yeah? So to avoid this local optima, we need to include more people. You need to diversify your team to reach and accomplish higher goals. So, okay. And then the second thing, representation matters. So for this one, let me show you some examples. So maybe you can feel what this means. Okay. So question. So among these pictures, can you recognize which one's American? It's hard, right? So I'll give you a hint. Half of them are just generic. So the prompt was just generic. Woman is painting and family is eating together, photo of a house. And the other half was customized for America, just United States. Still very hard, right? I can't even tell. Okay, so that's the truth. So these images were generated by one of the state-of-the-art text-to-image generator. And even if you have been using them, you probably haven't realized that there exists bias. Okay? So what about Korea? How are we represented in this space? Okay? So these are the images generated by Stable Diffusion. Okay. So I'll leave it up to you how you kind of assess the quality of the images. And like this is traditional Korean custom, but questionable. And then this, I don't want to show this to the fans, okay? But so this is how we are represented in this large model space. Okay. So representation matters, right? So we kind of understand the problem. And to tackle this problem, we need to first understand why this is happening. Okay? So the truth is, this particular model called the Stable Diffusion was trained on a data set called Lion. So Lion is the intent was great. So a lot of great big companies, they own the data, and all these like super performing large models were trained using really, really large data sets that they didn't release to public. So this group came up with an idea, okay, let's make a public data set that all the researchers can work on. So their intention was great, but because it's very expensive to create large data sets, they had to automate this process. So this is automatically collected and unfiltered. So they acknowledge there will be issues. And we also see these issues. So how do we tackle this? Okay? We cannot collect 6 billion text-to-image data and then label them properly. Okay? So quickly, what we try is using something called the priming. So priming is a concept used in human psychology. And when people have bias, it's very hard to shift your distribution inside very quickly. It doesn't happen that way. Like, I'm a woman, I'm an Asian, but I still carry the exact same bias when I'm sitting on the other side of the table. That's the bias. So knowing that there exists a bias doesn't fix it. And even if you are part of the discriminated group, still, you still carry the same kind of bias. Okay? So it's tough. But priming is one of the few methods that kind of was effective in fixing implicit bias quickly. So the idea is showing a few very positive examples right before the test. Then people suddenly kind of shift. So our technical idea is not exactly the same, but conceptually, that is the idea. We use very, very small amount of high quality data to refine the model. Okay? And luckily, I have students from 9 different countries. So we covered 9 places on the world map, and our goal is to put the dot everywhere, to include everyone in this like large models. Okay, so some qualitative examples. So Nigeria, whenever we ask about Nigeria, the country is just portrayed as such a poor country and people are starving kind of a situation. And now with our approach, it's generating more modernized Nigeria. Same thing for the houses, we can generate better images. So overall, the results, we are very happy with what we see, and they look great to us. But it's a science. Like in order to convince other people, we need quantitative result, which means numbers, like metrics. But evaluating something like this, cultural relevance or social compliance, things like that is super difficult. So that leads to the last part of the talk. So the evaluation challenge. Okay, so let me start with the quote from Galileo Galilei. So measure what is measurable and make measurable what is not so. And what we are trying to do is this second part, make measurable what is not so, which is super difficult. Okay, so let's see. So again, I'm going to kind of show you two different examples here. So first one, before we start, does everyone know what Turing test is? Yes? Okay. So Turing test is set up. You have kind of some agent performing some task behind the curtain, and then ask people, hey, do you think the other person who's doing the job is a human or not? And then if they pass the test, and they say they passed the AI system passed the Turing test. That means the AI system is as good as humans in that particular task. So it was a popular concept, and it was proposed in 1950. Like, I don't think you were even born, a lot of you, right? So this is a very, very old idea that's still around, okay? So my argument is kind of provocative thing, but based on the experiments that I kind of have done, Turing test doesn't reveal much anymore. So I'm going to tell you why. Okay. So the first experiment is on AI pilot, meaning we have a pilot that's kind of all fully automated, just like self-driving car. There is an area vehicle that is fully autonomous. So, okay. So the Turing-like test-like setting. So I mentioned this as a Turing test-like setting because we ask a lot more questions than do you think it's a human? Okay. So it's a similar setup, but we include a lot more questions. Okay. So in this setting, on one side we recruit pilots, and then the pilot is flying in simulation, and then on the other side, there's always a human pilot sitting, but sometimes the pilot doesn't do anything. It's just the same setting. It's all AI, or sometimes it's the human pilot actually flying. Okay, so the result from this study was interesting. So we had 26 FAA certified real pilots came in, and then assess the other pilots' performance based on many different criteria. Just like performance review. Like it's, as the AI part becomes more and more complex, it is not very different from evaluating human performance. So that's why it becomes much more complicated. So, and the good, the big takeaway here is it's very similar to what people found from self-driving industry too. So initially, people thought that if autonomous vehicle can explain what they're doing, maybe people will be happier. But that wasn't the case. People only trust and also accept autonomous systems when they perform really, really well. So competence is the key. It's kind of same as the human world. So we like nice people, but if nice people don't perform very well, it's not, the person is not going to stay for a long time because the job requires competence. So that kind of makes sense, and it is very consistent with the human world. Okay, and then for the Turing test, we found an interesting finding, which we expected, and the answers are kind of a 50-50 split. So people say it must be a human because they are awesome. The other half said they must be human. They changed lane like when they were not supposed to. They violated the rules. They went too fast. Their path looked ugly, whatever reason. So they're really bad. So must be human. So this is kind of an interesting observation, and also it indicates people's understanding of an AI system has also evolved. Like before, like in 1950s, like if you pass as a human, that was a great thing. But now, people actually believe that for some certain things, AI may be doing a better job, like following guidelines. Maybe AI, since it's an AI, like naive system, maybe they never violate rules, things like that. So people's expectation has evolved. So asking the Turing question doesn't really give us any insights when we develop technologies. So, okay. And then we had an opportunity to participate in this kind of fun experiment. So it was similar to the other Turing test. So again, it was Turing test-like setting with the museum audience. So, and Frida painting, one of the Frida painting, and the same, there was a person who was sitting as a model, and then there were 3 human painters doing the same painting, and then audience actually got to vote. So I'm gonna play the clip. So this was part of a documentary done by Australian Broadcasting Corporation. And on the actual shooting day, my flight got canceled, so I only showed up briefly. But this was really fun. And then at the museum, people were really taking a long time to make their decisions. It wasn't like, oh, obvious. And one side, there were painting contests, and on the other one, there was a photography, AI-generated photography and human photographers' work. And that one was super difficult because it was a digital space. So, okay. So on this one, the result, overall, Frida, got more votes as an AI system, but the interesting result was more than half of people voted some other human painters as an AI. So in a way, it is kind of, we can say, maybe Frida passed the Turing test. So this was an interesting experiment. Okay, so this measuring creativity, social compliance, and other things, these are just so difficult. So what do you do when you have a question and it's just bothering you and you just don't have clear answer? Then you just gather people around, like smarter people, and ask and have a discussion. So that's what I have been doing. So events like this is a great opportunity for people to discuss open-ended questions, because sometimes a lot of discussion leads us to nice answers. So I've been organizing a lot of workshops to discuss what creativity means, and also how we can measure, what's the metric? How can we put the numbers on this creativity space or the quality of the art, and so on. So, and after a series of these workshops, I was more confused, but I summarized the discussions into 4 different categories. Actually, 2 of them are very, very subjective, so it was a very noisy space. But there are 2 actually quite interesting directions that maybe will lead us to the right way. One is the context. So context means people want to evaluate anything that's given within existing context. They want to compare with what they have seen so far, what has been built so far. So that's great, because that's what we do in AI and machine learning. We always find patterns and compare and detect anomaly, what's the distance from the distribution, and so on. So on this direction, it's very promising. There are even some metrics that we can start using for evaluating creativity or novelty, other things. And the other one is a human values. So getting back to the original question, like what is a human value? And human values are the most vague and also very difficult ones to measure, right? But think about it. Among these human values, there's one thing that's in numbers, and we use it every day. Can you guess what that is? I know there are a lot of people from finance. Money. So anything that can turn into profit is a measurable because it's number. So, but there are greater human values that are priceless. Of course, there are things that we can never put a price tag. But think about a lot of things that we use in the normal, like daily lives. Everything has a price tag, and we are very good at giving quotes, even for new things. So this may be a way to kind of have a metric or some ways to evaluate our progress. Because we need this as a researcher. Without the guideline, like it's very hard to make progress if you don't have numbers in this space. Okay, so on this space, if you have any good ideas, please come talk to me, how to evaluate human values and human value-related topics. Okay, and again, this is the most open-ended question that we are facing. So the 2 that I just discussed is just ideas. So it's not like a definite answer or proposal, but something to consider and think about. So what's next? So the Frida painting was in 2D. So now we are working on the 3D side. So 3D means sculpting. So going into 3D, we are really getting to the most difficult part in robotics, which is deformable object manipulation and general manipulation. So manipulation has been very slow and super difficult, and even the planning space, because it had multiple joints, arm, fingers, and things, it's a high-dimensional space, so much more complex to plan, and efficiency is hard to achieve. So very difficult, but by just turning that into sculpting, everyone is having fun. So we now have a lot more students trying to join my group, and then also a lot more faculty members reach out to me to collaborate. So this has been amazing. And then the second part is the Frida. The original Frida was meant to help people to express ideas, but it was still kind of a one-shot. So I tell Frida, okay, I want to paint about war in Ukraine. that's it, like one shot. And now we want to make it really, really interactive system, going into the true collaboration. So, and it turned out that supporting that is super difficult. Like we initially thought that, oh, what can be so difficult? The difficult part is taking into somebody else's ideas into generation. Because now there are two agents trying to maybe going for the same goal, but the strokes, the actions are different. So it's like you've been working alone to achieve some goal, and you have an assistant who's messing things up. So adding more strokes that it's different from what I initially planned. So how to incorporate, coordinate those actions into the same goal turned out to be difficult. So we are currently working on that collaborative FRIDA, co-FRIDA, and we have some pretty good results already. So we will see, you will see the next version of FRIDA soon. So, okay. And then more broadly, the quest continues. So we strive to find this answer to this question: how can we contribute to make the world a better place, not just for me, but for us all. So, okay, so that's all I have for today. And then I'm gonna just play this random video while maybe take questions if anyone has questions. Too tired?
Can you hear me? Is it on? Excellent.
Yes.
Okay. Hello, I'm Professor Bissett from NHI Korea. Thank you so much for the presentation. Really enjoyed it. I'm not much of an artist, but my son is. So you seem to have a strong interest in its application for children, right? You talked about how that was the publication that you enjoyed the most. There's a lot of children and family of faculty members and things like that. How do you see integrating something like this in children's education? I mean, especially here in Korea, my son is 7 years old and he has art class right next to computer class, right? Like they're teaching them very young. So how can we kind of integrate those things together?
That's a good question. I really want to see how this can help the future generation, because I have this fear, like all the next generation will only use digital handwriting, or I don't know if they can do handwriting anymore. And drawing, I don't know if they have enough time to play. So if we build an application for education or just playing Playmate, then the robot will encourage children to play more. So come, paint more and make something with this Play-Doh. So with the sculpting, one thing that I'd like to do for children is making stop-motion movie. So maybe the children can leave their toys and then the robot kind of rearrange and create this stop-motion movie and then play it next day. So kind of engaging them to play more. I think playing is very important. And playing, creating art, that's essential for, especially for young children's life. I mean, that's what I think. I don't know if that answers your question. Yes.
안녕하십니까. 현재 대학생인 이병인이라고 합니다. 아까 객관적으로 인간의 가치를 평가할 수 있는 아이디어를 원하신다고 하셨는데, 만약에 AI가 객관적으로 인간의 가치를 평가할 수 있게 된다면 좀 위험할 수 있을 것 같다는 우려를 가지게 되는데요. 그에 대해서 어떻게 생각하시는지 여쭤봅니다.
네네네. 그거는 예, 굉장히 좋은 질문인데요. 예. So the question was, if AI is used to evaluate human performance, I think that's kind of a dangerous idea too. But there may be some things, like something like a standardized test. Then I think even the writing part is like rated by some system. So there are certain things that we can automate, but that kind of leads back to the ethics issue. So if any of these models are used to even hiring or like evaluating someone's performance, it has to be completely bias-free, which is difficult. I mean, even people have biases. And if bias is used in hiring, for instance, like in engineering and robotics field, you don't see a lot of female persons. So if gender becomes a strong feature, because let's say out of 10, 9 are male, so being male must be a very good indicator because that'll give me 90% accuracy. That's a strong feature, but which is wrong. So if that were used, then I won't be here. So, so I think that is a kind of a open-ended question, and I think that requires a lot more people to have a deep discussion, like including philosophers, people who are specialized in ethics. So even in small programs these days for like AI programs, we are required to include one person who is specialized in that category. So ethics is becoming part of requirement. So yeah, so I don't think I'm actually qualified to give you a clear answer to your question, but I think it is a very, very important question. So, yes.
예, 제가 기계공학을 나왔기 때문에 사실 컴퓨터공학이랑 인공지능 관련해서 내용은 정확히 잘 이해는 안 되지만요. 로봇을 보다 보니까 좀 현실적인 문제가 되게 궁금해서 사실 질문을 드리고 싶은데요. 되게 다양한 색깔을 쓰고 다양한 텍스처를 이렇게 이용해서 그림을 그리는 것 같아요. 그러면 뭐 붓을 색깔을 바꾼다든지 뭐 예를 들어 붓을 썼을 때 그러면 물을 해가지고 클린하게 정말 하고 새로운 색깔로 바꿀 거고, 아니면 예를 들면 물감이 말라가지고 원하는 어떤 텍스처가 나오지 않을 수도 있을 것 같아요. 이런 것들을 로봇이 직접 인지하고 그것을 구현하는지가 사실 궁금합니다.
Yeah. So the question was, the actual painting involves a lot more than just adding brush strokes because you need to wash the brush and change the color and mixing paints. So that's a great question. So some parts, Frida still is actually doing it, but some parts were like prepared. For instance, color mixing is still done by human. So we do a lot of color mixing. And we have a side project that has a mini robot that's doing the color mixing so that we can replace that job. And for washing the brush, it's almost engineered the solution. So the water ball is always there, so it knows that go to the known location, wash, and dip it in a cloth, and then go to the palette. So to simplify the problem for the research. So we currently focus only on the canvas, but those are like in the to-do list, so someday we want to include all of them. So great question. Yes.
First of all, thank you for your presentation. My question is kind of twofold. So I would like to know how far away you are from making a sculpture with Frida, And my second question is, there are a lot of AI generated images right now, and I'm curious how Frida's drawings compare to AI generated images.
Okay, great questions. So for sculpting, we are at a very early stage. So we are developing ideas so that the robot can do some shape-to-shape modification. And just to give you an idea, the state of the art in deformable object manipulation, so that's like changing the objects that are not rigid. And what people have been working on is cloth folding, you know, the like tower folding, or making alphabet with the Play-Doh. That's where we are, and even there's a state-of-the-art alphabets are not that perfect. So there's plenty of room to do research. So if anyone's interested in doing work, that's a great area to pursue. And your second question, like how is Frida like performing compared to the digital image creations? In digital image creation, the quality is amazing. As you saw in Midjourney, DALL-E, it can produce like photorealistic images, all kind of different styles, but turning that into the real space is a different story. So what we face in Frida project is that realization, because we need to actually take steps in real life. So we need to use some sort of a robot, and robot has constraints and also the real life constraints. So those are robotics challenges. And same thing for ChatGPT too. Like some people think ChatGPT is so smart and it can solve all the problems. And to some extent, yes. And for cooking, for instance, ask ChatGPT how to make like cream pasta, shrimp. It'll give you 2-page, like long, very detailed recipe. But who's going to do the cooking? So there is no connection between the recipes and the real world environment, context, what ingredients you have. So making those two together is the robotics challenge, because it requires sensing. Because in order to know what you have in your current environment, how do you know? Like you need to ask someone, language understanding, or you need to use your vision to assess, like semantic perception. And also you need to have some manipulation skills to open and doing cutting and stuff. And then you need the mobility too, because you can't just cook in one spot, so you need to move around. So it requires the full field of robotics to actually enable that. So taking this great success in AI into what we can really take advantage of in real life, that's the robotics challenge. And I argue that everyone should pay more attention to robotics and invest. Yeah. Okay. All right. Yes.
예, 공무원으로 근무하고 있는 강경호라고 합니다. 말씀 잘 들었습니다. 제가 드리고 싶은 질문은 교수님께서 프리다를 이용해서 만든 그림이 정말 인기가 있고 잘 그린 그림이 되어서 굉장히 비싸게 팔린다면 그러니까 그 돈은 누가 가져야 될 거라고 생각하십니까? 교수님인가요? 아니면 그 팀인가요? 아니면 그 컴퓨터 자체가 되어야 한다고 생각하시나요? 그 제작자로서의 의견을 좀 듣고 싶습니다.
Yeah, the question is if someone pays a lot of money for the paintings done by Frida, who owns that profit? So that's a good question. We are still kind of very short-term research funding, so we use kind of crowdsourcing and to raise the research fund. So we are not quite there yet, but many people actually approached me asking how much the painting is. So they always want to buy, and they think the paintings are expensive. We never thought about the price, but yeah, so that's kind of an open area. And if we turn this into a profit-making like company, I need to wear a different hat. And there are a lot more ideas how to turn this into a profit-making ones. I can kind of tell you more, but that's not going to be like selling paintings. But for painting, right now, if people pay, that'll just go directly to our research fund. So, yeah. Okay. Yes.
Hello, my name is Jung Juno. I'm a student attending the Seoul Christian School in Daejeon. My question is, how you want to expand through this AI Frida or other things, AI, or how you want to develop through this process?
How
to develop through this process?
How to develop the Frida process? Or, yeah, sorry.
AI를 통해 어떻게 더 사업을 확장시키거나 아니면 다른 하고 싶으신 게 있으신지 여쭤보고 싶어요.
Inside the Frida, like or
프리다를
outside.
통해서나 아니면은 그런 이제 AI로 통해서 그림을 그리는 방법을 통해서 어떻게 사업을 확장하고 싶으신지 여쭤보고 싶습니다.
Oh yeah, more commercial ideas from from Frida. Since it's creating content, one thing that I learned is people really like handmade ones. So anything, if you have a system that produces even tiny stickers, people like it. Like they take the stickers. And those are very human things. I mean, sometimes I don't understand why, but at the same time, I kind of understand because I'm also human. So they come and ask, hey, I really love this painting, but maybe can I take the poster copy of this painting? But look at this. These are not really great painting, but they still like it. And then, so anything that can produce tangible items, I think that it's a product. So, and handmade is like difficult to make, but if you use robots to produce something like handmade stuff, that could be maybe a commercial idea. But another idea is for helping children or helping people with disabilities, like people who are visually impaired. They cannot really enjoy painting, but if we turn that into 3D, they can touch and feel the shapes. So, but normally, if you go to a museum, there is a line. You're not supposed to go near the painting or a sculpting. You're not supposed to touch. But we want to produce something that people can feel free to touch and interact with. And those can be, I don't know, commercial products too. And just generally, this is good for mental health. So just as a companion type. So I haven't really kind of fully developed like commercializable ideas, but there are directions like education, and also another field that are very similar to this is manufacturing and construction. So in fact, a lot of these ideas that I had early on came from the cleaning project. So in one of the videos I played, so cleaning is the reverse section of painting. So you can apply the same idea to maybe paint the wall or make something on the like on the building. So those are all great directions. And as I said earlier, because it's art, it's in a very pure form. It's very applicable to anything that you want. So anything that you need to change shapes or paint over, these can be applications. So, okay. Mm-hmm. Okay. Any other questions? Yes.
예, 안녕하세요. 일단은 로봇 자체가 아주 확연히 개발된 로봇이 아니라 우리가 일반적으로 쓰는 로봇에서 산업용 로봇에 가깝기 때문에 교수님이 말씀하신 대로 구현의 한계가 분명히 있다. 관절이라든지 이런 쪽에. 근데 분명히 제가 볼 때는 이 부분이 우리가 지금 로봇공학 쪽으로 훨씬 더 발전해가지고 센서가 많이 부착돼서 저희의 손과 비슷한 능력을 가진 로봇에 적용이 된다면은, 그리고 협력하자고 하시는 다른 교수님들의 모든 아이디어가 한다 그러면은 분명히 저희가 이제 이런 표현을 하죠. 나는 그리고 싶은데 내 손이 똥손이야. 예. 그래서 실질적으로 노래를 못하지만 노래를 정말 잘할 것 같은 사람이 있을 거고, 예술가적으로. 네. 그림도 마찬가지라고 봅니다. 그러면은 이게 만약에 정말로 짧은 시간 내에 아니면은 먼 시간 내에 개발이 돼서 거의 내가 생각하는 거를 표현하고 싶다 그러면은 그걸로 통해서 분명히 예술 작품이 나올 수 있을 거라고 저는 기대가 됩니다. 그러면은 현재 사람이, 우리가 보통 돈을 받고 그림을 파는 순수 예술의 세계는 지금 되게 어떻게 보면 리스트릭트 하잖아요. 어떤 과정을 통과해서 다 대중적으로 다 인지가 돼야지만 가치, 휴먼의 가치가 되는데, 만약에 로봇이 이러한 나의 생각을 제대로 구현해 준 단계가 된다고 하면은 인간이 직접 그린 것만큼 이 프리다의 넥스트가 그러한 가치를 갖고 가격을 매김할 수 있을지, 그래서 상업할 수 있을지에 대해서 교수님의 의견을 좀 듣고 싶습니다.
Yeah, that's a good question. So, by the way, 3 of my students are designing anthropomorphic hands or new types of hands to actually do it, because you might have seen the first Frida didn't even have a hand. We taped the brush. So, yeah, so if we have a better hand, like maybe Frida can produce better quality painting, just like human painters, but it'll be just another painter. It's not going to be like something that's replacing artists' roles. So it is maybe something like, I don't know if it's similar to people taking selfies all the time, because they want to take some pictures, right? So in that sense, maybe they can take selfies with Frida, like Frida actually paints a lot of your selfies. I think that may be something, but it wouldn't be, I don't know, like in order to actually accomplish what you describe, I can start a company to actually like aim at that, towards that goal. Then I can maybe find a solution, commercial solution, but that's a very, very applied idea to me. Yeah, so, okay, I think the time is almost up, so, but great question. Yeah. Okay, any last question? All right. Then yeah, then thank you so much for staying late. Yeah. So, okay. All right. Thank you. 감사합니다.
Thank you again to Dr. Jin Oh for the enlightening words. Over the past 3 days, a feast of knowledge was held in numerous sessions under the theme of Techno Big Bang, Humanity on the Shoulders of Giants. This year's World Knowledge Forum will end here, and we look forward to your interest and support for the next year's World Knowledge Forum. I would like to express my sincere gratitude to all of you who have been with me until the end. Until now, I have been the host, 이세라. 지난 3일간 테크노 빅뱅, 거인의 어깨 위에 올라선 인류를 주제로 다양한 지식의 향연이 펼쳐졌습니다. 올해 세계지식포럼은 여기서 마무리하겠습니다. 내년 세계지식포럼에도 여러분들의 많은 관심과 참여 부탁드립니다. 끝까지 함께해 주신 여러분들께 진심으로 감사의 말씀을 드리며 지금까지 저는 아나운서 이세라였습니다. 고맙습니다.